So this video is going to look over the Chapter 2 review problems, numbers 81 on percent error, and then 84 and 85 on significant figures. So for percent error, you have an equation that would be given to you on the test, and that is equal to the error between your experimental and accepted value divided by the accepted value times 100. So for number 81A, for number 81, just period, the accepted length of steel pipe is 5.5 milliliters, or meters, excuse me. So in my equation here for the percent error, I want to know the error, which was the difference between the experimental and the accepted value divided by the accepted 5.5 meters. So that would be, they measured 5.2 meters minus 5.5 meters. That'll give us the difference, and then times 100. So 5.2 minus 5.5 is minus 0.3. We don't really care about positive or negative values. We just want to know how off we are in our measurements. So we don't care about that negative sign. And that answer, 0.3 divided by 5.5, is going to be, let's see, and then times 100 is 5.5%. And again, you don't have to do plus or minus. All right, for 81B, for this one, we've got, oh, super easy. Okay, so your accepted value was 5.5, right? And they measured 5.5. So you've got, if we're really going to fill in the equation, 0 divided by 500, it's going to be 0% because you got the right thing. I'm not even going to work through it. So because your value was the same as the accepted value, your percent error is none. You don't have any error. You're 0%. All right. So moving on to significant digits. So for significant digits, we want to, or sorry, they always say significant figures. I don't know why I say significant digits. So we're going to look at number 84. And they want us to round each figure to 3 significant figures. So 84A, our number is 0.003210 grams. And they want us to have 3 significant figures. So my 3 significant figures would be 3, 2, 1. I look over here at my 0, and it's less than 5. So my answer is going to be 0.00321 grams. All right, 84B. I've got 3.8754 kilograms, and I want to round it to 3 significant figures. So here are my 3 figures, and that's a 5. And I know the book talked about looking to see if the number was even and odd, and we're just going to do general rounding in this class. So it's going to go up to 3.88 kilograms. And finally, looking at, get all these on the same, 84C, we've got 219,034 meters, and we want to round that to 3 significant figures. So again, that's a 0 over there, so that's going to be 219,000 meters. Okay. So for the next problem, it's going to get a little bit trickier because you're going to be doing some calculations and then rounding the answers to the correct number of significant figures. So the first ones that we're going to look at, 85A, and in this one they're adding. So you've got 7.31 times 10 to the 4th plus 3.23 times 10 to the 3rd. And remember, when you're adding, you're only looking at the significant figures when you're using a decimal to the right of the decimal. So in my answer, because I have 2 in each of these, I've got to have 2 figures to the right of the decimal in my answer. Now, can I add these just as is? No, because the exponent values are not equal. So I'm going to change the 3.23, move the decimal point over here to 0.323 times 10 to the 4th. Okay. Now I can add them. So I'm going to have 7.31 plus 0.32 3, and that's going to give me 7.63. So 7.63 times 10 to the 4th. And that's correct because you've got 2 significant figures to the right of the decimal. Alright, so let's take a look at another one. Here we're going to subtract. So 85B, and we've got 8.54 times 10 to the negative 3 minus 3.41 times 10 to the negative 4. Okay, so again, the exponents are not the same. You'll notice one's negative 3, one's negative 4, so I've got to change that. So I'm going to go ahead and change 8.54, move the decimal over to the right to make it 85.4, and that'll be 10 to the negative 4th minus, again, 3.41 times 10 to the negative 4th. So now they're the same, so I can subtract 3.41 from 85.4, and I would get 82. Sorry, I'm looking at the numbers here. Okay, let's see, 85. I'll make sure that I'm doing it the way you would do it. 3.410. 81.99. Okay, so if it's 81.99, how many significant figures can I have? So I need to get this in a scientific notation first. So let's erase this. So 81.99 times 10 to the negative 4th. Let's get it in proper scientific notation before we round. So now we want to move the decimal point over, and that is going to then result in 8.199 times 10 to the negative 3, because I moved it to the left, making that number smaller. And because my answer, if I look at my values to begin with, I have 2 here, I have 2 on this side. I can have 2 significant figures to the right of the decimal. So this is going to round, the 9 is going to round this to 10, which then really rounds this to a 2. So your answer is going to be 8.20 times 10 to the negative 3rd. That was a little bit more complicated. All right, just a couple more. So our next one is 85C, I guess last one. All right, 85C. Sorry if this is kind of sloppy. It's my first time using this pen on my surface. But we've got 4.35. Pretty sure it's decimeter times 2.34 times 7.35. So now in this problem, we want to look at our significant figures, and you can only, when you're multiplying or dividing, your answer has to have the same significant figures as your least precise measurement. So this wasn't really a good example to give you guys because all of these have 3 significant figures. So your answer is going to have 3 significant figures as well. So if we multiply all of those out, you are going to get 74.8. We may have had to round that. I'm sure you did have to round that actually to 3. And don't forget to cube, because decimeter times decimeter times decimeter, decimeter is cubed. So that would be your answer. Sorry I didn't have a calculator, so I couldn't show you what your number was before you estimated. But again, have to have 3 significant figures in your answer. I hope that helped, and you can always ask more questions before the test on Thursday. Thanks.